All right, so the other day we did the special type that was difference of squares. Okay, so we talked about what happens when you have something like a plus b times a minus b and how that factors or that foils into a squared minus b squared. But what we actually did was what's in red there, the a squared minus b squared, and how that gives us a plus b times a minus b. So that was our special type of difference of squares. We also have the special type of the perfect square trinomial. So that would be something like the reverse of it, okay, would be if I told you to do a plus b squared, and then I told you that that's equal to a squared plus 2ab plus b squared, okay? That's what one of the options we had. Or a minus b squared is equal to a squared minus 2ab plus b squared. So that's what you've previously done, okay? You were given the left side and you had to get to the right side. But now it's reversed. You're given that right side, which is a squared plus 2ab plus b squared, and you have to tell us that it factors into a plus b squared, okay? Or the other one, if you're given a squared minus 2ab plus b squared, you should be able to say that this factors into a minus b squared. And this special type is a perfect square trinomial. Okay, I am known for giving bonus points if you can say what special type it is.
Perfect square.
Okay, so if you're given something that is one of the two special types and you give me the correct name for it, I give a bonus point on quizzes and tests.
Wait, if you what?
If you put the correct special type on your quiz or test, if it is one, then I give a bonus point for it.
Okay.
All right, so some examples of this. The beauty is that in your homework, it tells you in the first section what type you're dealing with, and it says to factor that type. On the quiz or the test, obviously my directions are just going to say factor, and you'll just have to recognize that it's a special type and what kind it is. Anyways. All right, so we're going to start with number 10. Y squared minus 10y plus 25. Okay, so the key to recognizing, okay, again, these instructions specifically tell you this is a special type, okay? But the key to recognizing why it's a special type, okay, we can imagine that there's a 1 here, okay? This is what squared?
5.
Okay, so that's 5 squared. So this is 1y squared. So then this middle term is 2 times a, which is going to be 1y or just y, times b, which is 5, okay, which factors into that. So that clues me in right there that it's a special type, okay? Again, this section tells you that it is. I'm just showing you on this first one why it is, okay? So then this factors into whatever this middle sign is what the sign ends up being, okay, in this. So that's going to literally just factor into y minus 5 squared. So if you recognize it's a special type, you don't have to show anything but that right there. So then for 12, 9t squared minus 12t plus 4. Okay, so at this one, again, I'm just going to show you what we're dealing with here first, and then we'll go through and we'll write it. I'll do it for the next one as well, and then go from there. But what squared gives you 9?
2.
Okay, so this is really 3t, and then all of that being squared. Okay, I'm rewriting it to try to help you see what the a term is. Okay, so what's inside the parentheses is a. A is being squared, as is in what I have written above.
Is there a 5 in parentheses?
Right here?
No, in 10.
Up here?
Yeah.
Right here?
No,
Or are you talking about right there?
Right there, yeah.
That's a 5.
Okay.
Okay, so minus, I'm going to leave that for a second. 4 is what squared?
2.
Okay, 2 squared. All right, so this middle term, okay, following the pattern 2 times A times B is 2 times A is what's inside this little parentheses, 3t times B, which is 2. So that 2 times that gives me 12. Okay. And so when I write my answer, it's A, so 3t, whatever the sign of this middle term is, minus B squared, which is 2 squared. Okay, so I'm trying to help you see why they're special types right now.
So, you know how we broke up? What? You know how we broke up? Oh, actually.
All right, 14. 2x squared plus 12xy plus 18y squared. Now, at initial glance, is 2 something squared?
No.
Okay.
Yes.
Well, okay, yes, technically. Is it a perfect square? No. Is 18 something squared? A perfect square?
No.
No. So, I need to do something to this to try to make them be perfect squares. Any ideas based on what you see of something that I can do to make them be a perfect square? Something that all the terms have in common, maybe. Okay, if I take a 2 out, then that leaves me with x squared plus 6xy plus 9y squared. Okay, now would we agree that my first and my last term are both perfect squares? Is x squared a perfect square? Okay. Is 9y squared a perfect square? Because what squared gives me 9? 3. Okay. So just to keep, again with this one, make sure you keep that 2 with it. Don't lose it. X squared, and then the last term is 3y, and then that whole thing squared. Okay, the middle term is 2 times a, which is x, times b, which is 3y in this case. Okay, so that factors into that. And again, the steps that I have written in green, you do not have to show me. I'm purely doing this right now so that you have it to go back and look at. Okay? So, my answer, I've got to keep that 2 out front. Okay, because I took it out, but it's not gone. It's a, which is x. The sign of the middle term, which is positive in this case, so x plus b is what's in parentheses here, this 3y. So x plus 3y squared. All right, so 16, I want you guys to try to walk me through what to do with this one. They use f's, so I'm going to switch them to x's just for convenience. So 4x squared minus 36x plus 81. I cannot do that because 81, I cannot take a 2 out of 81. You have to be able to take it out of all the pieces. Oh, you're saying, okay, gotcha. Okay, yes. So I'll go ahead and write that. So I'm actually going to write it as 2x and then that whole thing squared just so that we're keeping consistency that that's the a squared term. So 2x is a, okay, in the formula. Okay, so that's going to be 9 squared. So b is 9. Then what?
And then 2 times 9 times 2.
Okay. So my answer then is what?
Um, 2x.
What'd you say?
Plus 9.
Are you sure it's plus?
Minus 9.
Okay, it's whatever the sign in the middle term is, so it's going to be minus. Okay? All right, another one. Z squared plus 12z plus 36. If you want to. Okay, if you don't want to write the green step, you do not have to. Okay? If you just see right away, okay, what is my sign going to be in my parentheses?
Z plus 6.
Okay? So it's just whatever the first term is, whatever's being squared goes in the first thing, whatever's being squared in the last thing goes here, and then the whole thing's being squared. Okay? More often than not, if the first and the last thing are perfect squares, the middle is going to be something that makes it a perfect square trinomial. I don't think they're going to do anything to try to trick you in this book with that. Caught it. The Algebra 2 book, on the other hand, not so nice. But if you see that, then all you have to do is write whatever the first thing is that's being squared, whatever the second thing is that's being squared, and then keep the sign of the middle term and square the whole thing. So then with something like 20, got 45 r squared minus 120 rs plus 80 s squared. I'm going to change the s's to x's just for the sake that my s's tend to look like 5s, and I would prefer for that not to be confusing. So, are the first and last terms perfect squares? No. So what do I need to do to try to make them a perfect square?
You have to take something out of all of them.
It has to be the same thing that come out of all of them.
It's gonna say 15 in this amount, so can it just go up to 5?
Okay, let's try 5. And let's say that hypothetically it was 15. Okay, we're going to work it out and see. But if it was 15 and you took out a 5, it's still not going to give you a perfect square. You can just take out another 3 in that case, because that would have taken out a total of 15. So, take out a 5, leaves you with 9r squared minus, oh goodness, what is that? I literally can't. Hello. 120 divided by 5. 2, it's 10, 20, 24. 24 rx plus 80 divided by 5 is 16. Is that what you said? X squared. Okay. Now are my first and last terms perfect squares?
Yeah.
Okay. So now, don't forget about this 5 that's out front. Okay, so I'm going to go ahead and copy that down. What is the sign of my middle, or what is the sign of this going to be? Okay, it's going to be minus because the middle term is minus. So what goes in the A and the B spot?
3 and 4.
Okay, the numbers are 3 and 4. And then don't forget the variable R and X there. Okay, and just like we've been able to FOIL everything else, you could rewrite this as to check, you could rewrite this as 5 times 3r minus 4x times 3r minus 4x. You could FOIL this, okay, and then when you get that answer, you can multiply it all by 5, okay, and you can check it that way. So just like everything else, there is a way to check this one. Let's see, 24, 16m squared minus 8mn plus n squared. So what is this going to factor into? 4m minus n squared. Pretty simple. Any questions? We're good. We'll do one more. All right, one more example. If I had 2y squared minus 20y plus 50, what do I need to do? Take out a 2. So that leaves me with y squared minus 10y plus 25. Now what? Okay, and don't forget about the 2 out front. I don't know if you said that or not. Don't forget about that 2 out front. Okay, cool. Makes sense. All right, so then problems here that I would like you to work on. And then, like I said, tomorrow, there's a little bit more that we need to do with this section, as well as some reviews. So tomorrow, we might actually wrap up this section, which will also be a review. And then probably Thursday will be like a worksheet. And maybe a quiz on this on Friday. Okay, just because I like to do a quiz on every type of factoring, just because if you can't factor, like, you're going to struggle, and I don't want you to get to the test and then have all this different types of factoring and be, like, super confused. So this is the last official type of factoring. There's another section that's going to say, like, factor completely, which is going to involve, like, all the types of factoring that we've done, where it's just pulling something out, actually factoring with a number not out front, with a number out front, with the special types, okay, things like that. So that's kind of what the last section is, but I want to do a quiz on this section, so probably Friday, could be Monday, but let's plan for Friday. So the problems I would like you to do from this section, 9, 11, 13, and then under guided practice on page 601, I would also like you to do numbers 2 and 4. Okay, we just did number 3.
What page is the homework?
The homework itself is on page 603. Okay, but I also would like you to do these 2 problems. This is the last of those examples, because all of the one section were evens.
Did you say 2 and 4?
Yeah. And actually, I would like you to also look at 22 on page 603 and see if you can find the error and correct it. Okay, number 22, it's one of these where it says describe and correct the error. So see if you can figure out what they did wrong and then fix it. Okay? Yes.